All right, welcome back to some notes. So this is Unit 7, Day 6 notes is on page 31. We're going to move on to the next couple graphs. These are going to be secant and cosecant graphs. I filled out what the unit circle looks like at, again, 0 and 2 pi, pi over 2, pi, and 3 pi over 2. So nothing new there. So remember, secant is the reverse of cosine, meaning secant and cosine are reciprocals, meaning if cosine was 1/4 means secant is 4. So they're going different ways. So that's kind of what the graphs are going to do. They are reciprocal graphs. So if one's getting smaller, the other one's getting bigger. So like if one's getting smaller here, 1/4 or 1/10, one's going to 10. And that's what the graphs are visually going to represent. Okay, so from the unit circle, at cosine, so cosine, remember cosine is the x value. Cosine 0 is 1. At pi over 2 is 0. At pi is -1. 3 pi over 2 is 0. And at 2 pi, again, we have 1. So based on these, remember we do reciprocals. So this is 1/1, so if I flip it, I still get a value of 1. So at cosine 0, which is 0/1, secant is 1/0, which is undefined. Okay, that means we are actually going to have a vertical asymptote. Okay, and I'll show you how to get these real quick, and nothing you have to calculate or anything, just work it through. So at -1, so -1/1 is still -1/1. Sorry, 1/-1, so -1. 0 again is just like the one up here, is 0/1. I flip it, I get 1/0. Again, that's undefined. So it's a vertical asymptote. Again, I have 1 here, so I get 1. I'm not going to ask you about this stuff down here, so don't worry about that. All right, so whenever you're asked to graph secant or cosecant, you want to graph their partner function. So graph cosine first. So keep all the numbers the same. Just whatever you do, change it. If it's a 3 secant x, change it to 3 cosine x. So graph cosine x first. So whatever numbers are here, use them, put them into the cosine and graph that first. So we're doing the same thing. All right, so a value is 1, b is 1, period is 2 pi over b, so still 2 pi. My interval is 2 pi over 4, which is pi over 2. So all that stays exactly the same. So it seems odd at first, but I'll show you why. Graph cosine of x, and then we'll get the secant graph off of that. So my start point is at x = 0. I count by pi over 2. Okay. My cosine goes up to 1 for my amplitude. I start here, and I go here, and again here, here, and here. So you can vaguely see what the cosine graph is if I ask you to graph it. If you want to graph it, go for it. Now remember, down here when we talked about this, when cosine is 0, secant is undefined. That means I'm vertical asymptote. So it's at pi over 2. Anytime you see the cosine hit what would be the 0 or the 0 line for cosine, this is a asymptote here for the secant graph, which is ultimately what we're doing. Again, anytime you see a 0 on this, you're going to have a vertical asymptote here, which is the part of the secant graph. All right, so what happens is when cosine is 1, secant is also 1. So here we get 1. When cosine was -1, secant was -1. They attach to each other at the highs and the lows. So the maximums and the minimums, they are actually going to be in both graphs, so the extrema. And for this one, they're going to attach here. Now the thing is, they're reciprocal, so they go opposite directions. When cosine goes low, secant goes high. So the graph actually goes, secant graph actually goes up like this, because cosine goes there. Okay, when it's low, it's high, so it goes the reverse way that the cosine graph goes. That's all. So the little dotted line in here is the cosine curve. Everything else, the solid lines are the asymptotes, and then you have like the parabolas going in the opposite directions. These are the secant graphs. That's all you have to do to graph it. All right, so on the next page we have the same thing, but we have cosecant. Wait, what did I do? Oh no, haha, just kidding. I switched it, I left it as a secant graph for you to do. Okay, so I have another one for you to do. All right, so like I said, if there are numbers there, keep the numbers there. So graph what cosine 2x looks like. So amplitude is 1, period is 2 pi over b, so b is 2, so it's pi. Start value is 0. Interval is pi over 4. Okay, it goes up to 1 and negative 1, start at 0, pi over 4, pi over 2, 3 pi over 4, and pi. Alright, so cosine curve. Again, think about the cosine curve. Okay, there, 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 and there. Sorry, I need some points first, don't I? Okay, so we got that, and got that. Okay, since there's my cosine curve, so that's my initial. Now I start going to the secant curve. Whenever there's a 0, it means the secant is undefined, so it means a vertical asymptote. Okay, they attach to each other at the maxes and they go the reverse direction. So that one goes here, and then this one goes up here. So it's always the same sort of shape based off the cosine curve. And so next, when I do the cosecant, I am basing it off of the sine curve. So you're doing the same thing. So I got these. All right, so again, sine value 0, 0, 1, 0, negative 1, 0. Don't worry about the bottom here. Okay, the reverse. When it's 0, the reciprocal is cosecant is undefined because it is 1 over 0. Which gives me a vertical asymptote. When it's 1, I still get 1. When it's 0, again, same like the top one, I get 1 over 0, so it's undefined. A vertical asymptote. So yes, you're starting to see patterns. Anytime you have a 0 on the sine function, it means the cosecant one is undefined, so you have vertical asymptotes. So we get negative 1. Alright, so again, you want to graph its partner function. So cosecant, you want to graph sine of x first. Okay, so same thing. A is 1, B is 1. No horizontal, no vertical shifts. My period is 2 pi. Interval is pi over 2. So then I have sine graph. So sine's here, 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 and here. So the sine curve would be coming like this, and this, and this, and this. Oops, sorry. So you see the sine curve that you've been doing. Anytime we have the 0 on the sine curve, the cosecant is undefined. So you start making asymptotes through the zeros. Okay, and so anytime it's 1 here for the sine, it's 1 for the cosecant, so it goes reverse direction. It's a reciprocal. And same thing here, negative 1 goes the other way. Alright, that's where we stop the notes. Talk to you tomorrow. Bye.